From the stunning new radio image of the Milky Way to the dancing dwarf galaxies predicting our future and the existential crisis we're potentially yet to face about minerals for renewable resources, this is your wrap of Talkin' Science this week. Astronomers from the International Centre of Radio Astronomy Research have created the largest low-frequency radio colour image of the Milky Way ever assembled, which provides astronomers with new ways to explore the birth, evolution and death of stars in our galaxy. Silvia Mantovaniani, a PhD student at the Curtin University node of ICRA, dedicated 18 months and over 40,000 hours to construct the image using the supercomputers at the Pawsey Supercomputing Research Centre to process and compile the data from two extensive surveys. Those were conducted using the Murchison Wide Field Array Telescope located at the CSIRO Murchison Radio Astronomy Observatory on Wiradjuri Yamaji country in Western Australia. These were the Galactic and Extragalactic All-Sky MWA or GLEAM and the GLEAM Extended or GLEAM-X surveys, respectively conducted over 28 nights in 2013 and 2014 and 113 nights from 2018 to 2020. The new image, which focuses on our own galaxy, offers twice the resolution, 10 times the sensitivity, and covers twice the area compared to the previous GLEAM image released in 2019. This significant improvement in resolution, sensitivity, and sky coverage allows for a more detailed and comprehensive study of the Milky Way, providing astronomers with a wealth of new data and insights. The image allows them to distinguish between the gas surrounding new stars and that left behind by dead ones, revealing clearer patterns in the cosmic landscape. A cosmic dance could be the future of the Milky Way as it tracks a course to collide with neighbouring galaxies, a University of Queensland survey has found. Dr. Sarah Sweet from the School of Mathematics and Physics is the leading delegate of a collaborative survey with the Australian National University's Research School of Astronomy and Astrophysics, among others, which aims to understand if the evolution of Earth's home galaxy is typical of what is seen in other parts of the universe. The Milky Way will merge with Andromeda and their respective smaller dwarf galaxies in the next 2.5 billion years. And while there has been a lot of research into what's happening in our local group, we don't know how typical it is, Dr. Sweet said. Research paper lead ANU Professor Helmut Jurgen said the researchers were comparing our local galaxy group to other twin-like systems. The research was published in monthly notices of the Royal Astronomical Society. A flexible robotic sheet that can grasp objects and move across surfaces could improve autonomous systems in fields such as exploration, haptic displays, and smart healthcare, according to international researchers. The team engineered a robotic folding sheet made with densely distributed heat-sensitive electrical elements that can change shape when exposed to heat, and used it to crawl across a surface and grasp and lift objects in the lab, including a petri dish, plastic packaging, and a wooden stick. The researchers suggest that the folding sheet can improve the versatility and adaptability of autonomous systems, allowing them to more effectively function on unpredictable terrain. However, they say that further advances in material technology and structural design are needed to fully harness the potential of this technology. Australian and international scientists have found new evidence that may support a controversial idea that a comet exploded over the Earth around 12,800 years ago. The controversial Younger Dryas impact hypothesis, which was featured in the Netflix series Ancient Apocalypse, is based on the idea that a comet exploded over the Earth and triggered a period of abrupt climate cooling and species extinctions. But the idea is widely debated, and it is more generally accepted that the cooling was caused by glacial meltwater. The researchers, however, say they have found evidence of this impact in deep marine sediments from Baffin Bay off the coast of Greenland. The analysis detected metallic debris whose geochemistry is consistent with comet dust. These occurred alongside microscopic spherical particles whose composition indicates a mostly terrestrial origin, with some materials believed to be extraterrestrial, suggesting these microspherules could have formed when comet fragments exploded just above or upon hitting the ground, melting materials together. The analysis also uncovered even smaller nanoparticles with high levels of platinum, iridium, nickel, and cobalt, which can be signs of extraterrestrial origin. Together, these findings indicate a geochemical anomaly occurring around when the Younger Dryas event began. However, they do not provide direct evidence supporting the impact hypothesis. More research is needed to confirm whether the findings are indeed evidence of impact and to firmly link an impact to climate cooling. The world is likely to come up against several shortages of critical minerals while transitioning to low-carbon sources of energy, according to international researchers. Looking at climate change mitigation proposals from the Intergovernmental Panel on Climate Change, the researchers assessed the likely demand and risks of shortages of 40 minerals needed for 17 technologies, including indium, iridium, tin, lithium, and silver, which are used for technologies such as solar, wind, and nuclear power. They say the world will likely experience shortages of up to 12 minerals by 2100, with the Middle East and Africa likely to see additional shortages. The researchers say we need to be prepared for these risks, which could be managed through aggressive recycling, substituting materials, trade cooperation, and diverse energy portfolios. The authors also note that these shortages could be addressed by substituting technologies for higher efficiency options, such as replacing current cobalt-containing battery systems with alternatives such as lithium iron phosphate, although this approach could then increase shortages of other minerals. More broadly, the study's authors, Yiming Wei and colleagues, suggest closer trade cooperation among nations and increasing recycling efficiency will mitigate those potential mineral shortages out of everything. Daily Science and Space stories with an Aussie flair, plus a deep dive into the science or space headline of the week, and the occasional science fiction podcast. Like, follow and subscribe for more. Membership available to help us do more. That's at thetrek.zone/support. This is Trek Science, talking science.